Okay, good morning everyone. Welcome to our class. So today we are going to discuss about the MN chapter. So here we are only focus on the question paper, previous year questions. Okay. So in the previous year question paper, we try to discuss the theory of this chapter. Okay. So let's start. First, once again, everyone, welcome. Okay. So we know this MN, this is the derivative of ammonia. Like if we replace hydrogen of this ammonia, then we will have different hydrocarbon for that one, for different amines for this one. Okay. So let's discuss this one. Okay, so prior to that one, just wait. Okay, sorry for a technical problem. Okay, so let's discuss about. So we are discussing about the MN chapter. So you know this MN is the derivative of ammonia. So if we replace hydrogen of this ammonia, then we'll have different type of amines. Okay. So with that one, so let's discuss about today's class. So you know this in this class we are discussing about the previous. Okay, so with that one, let's discuss the first question. So everyone, please try to solve this one. Just go to the question. After that, we will discuss this. Okay? Okay, so let's discuss this one. So here the question is, which of the following is combined to methanamine? Amine of 2 carbon. Okay, so this one. and we have to convert this into which one? We have to convert this into methanamine, NH2. So how to do this one? We know this. To reduce the number of carbon, okay, in a particular chain, we have to use Hofmann hypobromide reaction, okay, in which we just omit this group. So if we use one Hofmann bromide reaction, then we'll omit this one. So we can say if we take this one, CONH2. Okay, and if we take bromine, then we have this one CH3 CO. Sorry. Okay, so we just omit the CO group and we will have NH2. So I hope you know the mechanism of this one. Okay. And after the state and definition reaction is simple. Okay, we are taking the nitro group. After that, we reduce this with SnCl to HCl, and it will give us the MN. But whatever the number of initial you have taken, you will get the final same number of carbon. And Gabriel-Thallimide method is we have to take this one. Okay. And if we react this with some base, okay, after that Rx, then we'll have some primary amine. Okay, primary amine will get NH2. Okay, but whatever the number of carbon here, it will retain here. Okay. And this is the reaction we are taking isocyanate, okay, in the presence of this one like R, NC, chloroform, CaHCl3, okay, KH, then we will have this one R, NH2, CH2. Okay, so we will get this one. So is the correct answer for this one, conversion of this one, A is the correct answer. I hope you understood this. And I expect you to remember mechanism, all these things. Okay, so let's proceed for the next question. I hope you understood this one. If you have any issue, just let me know in the chat, or you can just directly ask me. Okay, so let's go to the next. The question is method by which aniline cannot be prepared. Okay, so in which method aniline we cannot prepare? So what is the formula of aniline? Aniline is the aromatic amine. So this is our aniline. Okay, so now let's see one by one method. So degradation of benzene amide with bromine alkaline solution. So benzene amide first we will draw. Okay, we are checking the option first. This is our benzene. Okay, and after that, this is our benzene amide. So if I take this one with Br2 KH, so tell me what is the product we will get. So we will get this one, benzene. Okay, C after that NH2. So we will get the aniline. Because if we take this one, then this particular thing will omit. Okay, and we will get this product. Everyone understood this? YouTube people, everyone understood this? Okay. Everyone understood this? So this we get the benzene or aniline. Okay, after that, let's take the second one. So option B is we have a reduction of nitrobenzene with hydrogen in the presence of palladium in ethanol. So we are taking nitrobenzene NO2. Okay, we try to reduce it with the help of hydrogen in palladium in the ethanol, like ethanol. So we can say CH3COH. H2. Okay, CH3CH2OH. Okay, in this medium. So you know this can reduce this into amines. The nitro group can be reduced to NH2 group by hydrogen in palladium. So we can have aniline here also. Okay. Now let's see the third one. Third one में क्या होगा? Potassium salt of thaliamide treated with chlorobenzene followed by hydrolysis with the aqueous solution. Okay, so let me write this one. The question is, we are taking sodium salt of thaliamide. So we are taking like this, CO. This is potassium salt. Okay, and after that we are taking this one, Cl. Okay, so we are expecting the answer should be like this: NH2 plus K2CO3, okay, plus H2O, like, okay. But remember, and KCl. But remember, this method can be used for the aliphatic ring on aliphatic compound only, not this aromatic. Why? Because we have partial double bond due to resonance. So if we see the chlorobenzene, then we can say this bond, chlorine and carbon, and partial double bond due to resonance. Okay, that is why we cannot easily break this bond due to resonance. This one, this is partial double bond, so we cannot break this bond. If we cannot do this, means what? We cannot have this amines. Okay, so we can say we cannot use this method to prepare, or we can say this particular thalidomide method is used to produce that amine of aliphatic. Okay, aliphatic amine. Okay, not the aromatic. You understood this? So our answer is this one, because we have to find out the process in which we cannot produce. So the correct answer is this. Then obviously this is not the answer. Okay, everyone understood this? I hope you understood this. Like initially we have used in this one. Here I have taken here. So is aliphatic one, not the aromatic here. Okay. Everyone understood na? Gravel thalidomide synthesis is used for the aliphatic, not the aromatic. Everyone understood this? Let's proceed for the next question. Okay, so now solve this one. So here what? So everything is fine. Okay. So tell me this one, how to find out option D. So here we are given this one, bromobenzoic acid react with SOCl2. After that we have to add NH3, and after that bromine in the presence of NaOH. So what is the product D? We have to find out. Okay. So like we are about to give the exam. Okay, exam is narrow to us. I expect you have to remember like most of the theory. Okay, so I need not go through that much deep into the theory, but I will tell like how to proceed. Okay. So we know this. Whenever any carboxylic group react with SOCl2, so what is the trick we are using? Okay. So the trick is like this. For example, we have any carboxylic acid RCOOH. You write like this. After that, if you are reacting with SOCl2, so how will write this? Structure of Cl2 is like this: SOCl. Okay. SOCl2. SOCl2. Okay, so I have to put like this. Okay, so I have to break this into three parts. So this is here we will put Cl, SOCl. So this is not a mechanism but a trick to remember this one. So SOCl2 react with carboxylic acid, so we will have RCOCl, okay, plus SO2 plus HCl. This is the product we will get if we adding SOCl2 with carboxylic acid. Okay. So according to this, what is the answer we will get? So we can say this wala part will go with the chlorine, and this oxygen with SO, and this with chlorine. So what is the product we will get? The product we will get the B. The B is this one, COCl, and bromine is here. And after that, what we will do? We are adding NH3. So what answer we will get? We know this. Whenever we have any carbonyl carbon, so I am writing here, whenever we have any carbonyl carbon, okay, so let's take the SL group only, Cl, and if we add this with ammonia, so what will happen? The lone pair of this ammonia and this is leaving to leave the compound, so we'll have RCO, and here we have NH2 plus HCl. Okay, because nitrogen can form only three bond. Okay, so here we will get this one. Okay, here we have CO, NH2, okay, and here we have bromine. Then which is the correct answer? The correct answer is this. everyone, you understood, na? You have to understand how they are reacting. Like if you are taking carboxylic acid SOCl2, how they proceed. Okay, and ammonia, how it reacts with acyl group. Okay, so you are supposed to know this. Just remember, whenever you have any carbonyl carbon and ammonia, okay, the lone pair of this ammonia attack that carbonyl. Okay, okay. So shall we proceed then? Okay, so let's proceed. This is our next question. So the question is, which of the following amine will give the carbon test? Okay, we know this. What is the carbon test? So if you are taking any primary amines, if you are taking any primary amines like this, H2, and here CH, Cl3 base, then we can say it will give us RNC, thiocyanide. Okay, so this is test for primary amine. So let's see among these four, which is the primary amine. Okay. So if we consider this one, so this particular carbon is attached to one carbon. So this is 1 degree. And this carbon attached to this and this one. So degree is second degree. Okay, this is second degree carbon. And after that, this one, this particular carbon is attached to here to carbon, here to carbon. So degree is 3. And here, this carbon is attached to this carbon and this carbon. So degree is 2. So now tell me, among these, which will give the carbon element test? Obviously, we know this carbon element test is given by carbonyl carbon. Okay, sorry. Carbon element test is given by the primary element. Which is the primary element? This is our primary element. So the correct answer is this one. Everyone understood this? How to solve this type of question? First, you have to know what is in the carbon element test. We know this carbon element test is a test for primary elements. What is the reagent chloroform in the basic medium? Okay. I hope everyone understood this. Yes or no? Everyone understood this? In YouTube also. Okay. So shall we proceed then? Okay. So let's go to the next question. Guys, if you have any doubt or anything, just put, write in the chat. Okay. Or you can ask me directly. Okay. No problem. Everyone understood this? Okay. So let's proceed for the next question. Okay. So this one. The question is, the correct order of basic strength of the methyl substituent amine is in aqueous. You have to find out what is its strength in aqueous medium. Okay. You have to find in aqueous medium. Okay. So we know this. How to find out basicity of the amines? We know this. Suppose what is the basicity? The tendency to donate electron. Okay. So if we have more R group, if we have more R group, then it can push more electron due to plus I effect. So we can say basicity of this one is more. But this is in the case of gaseous form. If the ammonia is in gaseous form, then we can use this logic. Okay. More the R group, more is the capacity to donate electron. Okay. But this is we are having aqueous solution. Okay. So to find out the basicity of this particular amines, what we'll do, we have to consider stability of that ammonium cation. Okay, so suppose this is our RNH2. So what it will do, when you put this in the water, okay, it will abstract hydrogen from here and will have this one RNH3 plus, okay, and this is OH minus. So more the stability of this one, okay, more is the basicity. Okay. So this is affected by these three. First one is plus I effect of R group. Okay. After the steric hindrance, okay. And after this tendency to form hydrogen bond. You understood this? So if we see the 1 degree amines, 1 degree, 2 degree, and 3 degree. All the three factors have a 2 degree amines. All these three factors have a 2 degree amines. Okay, so we can say more basic in nature in aqueous medium is this one 2 degree amines. So we can say CH3 2NH. This is 2 degree. Okay. After that, it is depend if this R group, this R group, na, so if we consider NH2, if R group is smaller like methane, okay, then steric hindrance is less. So more basic is which one? This methyl, this 1 degree, CH3 NH2. Okay, and that means after this one is CH3 all 3 NH. Sorry, this one. Yes. Okay, so this one. Okay, so this is NH. Everyone understood this. But if you're taking like R group is bulkier one, like C2H5. So in that case, well, the basicity order is this one. Basicity order is 2 degree, 3 degree, and after that 1 degree. I hope everyone understood this. सभी को ये समझ में आया? ठीक है. Shall we go for the next then? ठीक है, ये समझ में आया. तो हम चलो next चलते हैं. Next हम this one. ठीक है. The amine that react with Hinsberg reagent to give alkaline insoluble product. ठीक है. तो Hinsberg test क्या होता है? This is the test for the amines, primary amine, secondary amine, tertiary amine. ठीक है. So what is Hinsberg reagent? So this is benzyl sulfonyl chloride. ठीक है. For example, ये अगर तुम्हारा NH2 होता, ठीक है, so what I told you, it will attack the electron deficient, ठीक है, और जिसके पास थोड़ा deficiency होगा, so like this one. So if, then we can have this one R NH, ठीक है, और ये हो जाएगा तुम्हारा S CO and this one is इतना हो गया. ठीक है, सही किया मैंने. ठीक है. सो दिस वन. सो नाउ सी, इसमें जो होगा ना हमारा ये वाला, इसमें ये हाइड्रोजन, ठीक है, हमारे पास ये हाइड्रोजन है. सो व्हाट वी कैन से, अगर तुम्हारा इफ दिस NaOH एसिड हाइड्रोजन हियर H, तो इसके साथ वो सोल्यूबल सॉल्ट बनाएगा. ठीक है. बट इफ यू टेकिंग द सेकेंडरी एमिन, जिस मान लो तुम्हारा R है N, ये तुम्हारा R प्राइम एंड दिस इज NH. सो सेम इट विल रिएक्ट विद दिस वन. ये तुम्हारा बेंजीन है, ठीक है, बेंजीन SOCl. ठीक है. सो दिस वन विल अटैक हियर एंड ये इधर चला जाएगा. तो व्हाट विल गेट R N, दिस R प्राइम. ठीक है, और ये इधर चला आएगा क्योंकि प्लस हो जाएगा. सो यू विल हैव दिस वन SO और इधर हो जाएगा तुम्हारा ऐसा. तो मैंने इसको, ठीक है, like this. So now here you can see we don't have any acidic hydrogen. So what we can say, ये तुम्हारा if we put this in NaOH solution it will not proceed. समझे? और if you take the tertiary amines, अगर तुम इसको ऐसे लेते हो R double prime, ठीक है, what will happen? It will not react. ये तुम्हारा Hinsberg उसे नहीं करेगा reagent से, it will not react. समझे? So by this way we can identify primary amine, secondary amine and tertiary. ये सभी को समझ में आया? एवरीवन अंडरस्टूड दिस? यूट्यूब में भी सभी को समझ में आया? ठीक है. यूट्यूब में कोई कुछ बोल रहा है क्या? ठीक है. तो ठीक है, एवरीवन अंडरस्टूड दिस? सो द करेक्ट आंसर कौन सा होगा इसमें देखते हैं. सेकेंडरी मींस कौन सा होगा? सेकेंडरी मींस ये 2 कार्बन से जुड़ा है, ये सेकेंडरी होगा. ये तुम्हारा 3 डिग्री होगा. ये तुम्हारा प्राइमरी है, सॉरी ये तुम्हारा प्राइमरी है एंड दिस वन इज प्राइमरी. सो द करेक्ट आंसर इज दिस वन. तो हमारा करेक्ट आंसर कौन सा होगा? करेक्ट आंसर होगा हमारे. ठीक है. आई होप कि सभी को समझ में आया. समझ में आया ना सभी को? ओके. सो शैल वी प्रोसीड फॉर द नेक्स्ट? ओके, लेट्स गो फॉर द नेक्स्ट. ट्राई टू सॉल्व दिस वन. क्वेश्चन इज nitration of aniline in strong acidic medium also give meta nitroaniline. ठीक है, meta nitroaniline. So what is meta nitroaniline? So meta nitroaniline is this one. This is our aniline. Okay, and at meta position we have nitro. Okay, the question is usually what happen because the aniline NH2 group is a electron donating group, so it's supposed to give us ortho and para product, but in the nitrogen in a strong acidic medium it also gives some meta product. So why these things happening? Why these things happening? Okay, so you have to find out that. Okay, so okay, let's do. So if you're doing nitrogen of this one, H2SO4. So what will happen? Because this is our basic medium, na? Medium. Sorry. This NH2 is a basic in nature, and this is our acidic medium. What will happen? It is possible that if you take the strong acidic medium, so what will happen? This group will accept one hydrogen and it become N3 plus one hydrogen from here and H plus. Now this NH3 group don't have lone pair to, so now it will not act as an electron donating group, rather it will act as an electron withdrawing group due to minus I effect. Minus I effect. Okay, minus I effect. Now we can say this also can act as a electron withdrawing group. Because of that, sometime it will give you meta product also. It will give you NH2. Okay, and this is NO2. Because after if you do the nitration of this one, meta product, because NH3 plus is an electron withdrawing group due to minus I. So let's the answer, which is the correct answer. In spite of substituent nitro group always go for meta position. No. Electrophilic substitution reaction amino group the meta attack. No. In the absence of substituent, nitro group always goes to the meta position. No. In acidic, which is strong, aniline is present as aniline ion. Aniline ion. This one is our aniline ion. Okay. Have you understood this? Because of this aniline ion, it acts as a electron group, this particular group. So it will give us the meta product. So the correct answer is this one. Which is the correct answer? This one. I hope you understood this. ये सभी को समझ में आया. Shall we go for the next? Thumbs up दे दो everyone if you are understood this. ठीक है, हम चलो आगे चलते हैं. ठीक है, आगे बढ़ते हैं. Okay. Question is the correct increasing order of basic strength. Okay, so you have to find out which is the basic strength. ठीक है, तो better we first again to you. Usually what I doing, I find out the acidic strength. Okay, and which is the reverse of the basic strength. ऐसे रहता है. ठीक, उल्टा भी कर सकते हैं. ठीक है. So which is the basic strength? Basic strength. Okay. Basic strength. Strength किस पे डायरेक्ट प्रोपोर्शनल है? डायरेक्ट प्रोपोर्शनल टू प्लस आई ग्रुप. More the plus I group, more strength. Okay, or plus M group, and this is inverse proportional to 1 by 2. ठीक है, and which is inverse proportional to minus M group. Okay, so likewise that. Okay, now let's see. Among these, like if you see carefully 3 of them, then we can tell in aniline is a मान लो कि reference है. First, when we are adding methyl group, it will become an electron donating group. Okay, and if you add a group, it will become a electron withdrawing group. Okay, so here we can say it is pushing the electron. Here we can say electron. So we can say this second wala group is a more acidic compared to both of them. इसका basicity सबसे least होगा. तो second है basicity इसमें, तो we have option C and D. C and D. After that, if we see third one, अगर हम तीसरा वाले को देखते हैं, उसमें तुम्हारा क्या है? मिथाइल कुछ पुशिंग द इलेक्ट्रॉन, क्योंकि वो इलेक्ट्रॉन पुश कर रहा है, वो इधर इलेक्ट्रॉन देखो, इट इज पुशिंग द इलेक्ट्रॉन, सो इसमें बहुत हो जाएगा, इलेक्ट्रॉन डेंसिटी विल इंक्रीजिंग. दैट मींस दिस नाइट्रोजन बिकम इलेक्ट्रॉन रिच, अमीर हो जाएगा ना, इट कैन इजीली डोनेट इलेक्ट्रॉन. ठीक है, क्योंकि वो इजीली डोनेट कर पा रहा है, तो वी कैन से मोर. सो हमारा मोर बेसिक कौन सा होगा? मोर बेसिक इज थर्ड वन. सो द करेक्ट आंसर. ये सभी को समझ में आया? सिंपल सा है. जो इलेक्ट्रॉन डोनेट करेगा, जैसा होता है ना, हम कब खुश होते हैं जब हमारे अच्छे दोस्त होंगे, अच्छे जो तुम्हें सब कुछ दे, एटलीस्ट पैसा तो दे दे, ठीक है, ऐसा वाला. और कंजूस फ्रेंड होगा तो तुम भी गरीब हो, दे नहीं पाएंगे. और विथ रेस्पेक्ट टू इलेक्ट्रॉन, द ग्रुप व्हिच कैन नॉट डोनेट द इलेक्ट्रॉन, इट एक्ट एज एसिडिक वन, बिकॉज़ इट हैव टेंडेंसी टू पुल द इलेक्ट्रॉन. सुनिए, तो तुम गरीब हो तो भाई किसी को पैसा मांग लाइक दैट, ठीक है। सो आई होप यू अंडरस्टूड दिस। चलिए गो फॉर द नेक्स्ट। ठीक है, चलो, ठीक है। ठीक है, इसको देखो भाई, ये बहुत मतलब बड़ा बड़ा थियरी बट सिंपल। द करेक्ट स्टेटमेंट रिगार्डिंग बेसिसिटी ऑफ एराइलेमिन, हम क्या करेंगे, ये हमारा एराइलेमिन, ठीक है, ये तुम्हारा एराइलेमिन है, एंड वी हैव टू सी व्हाट इज द बेसिसिटी ऑफ दिस वन, ठीक है, मतलब इसके रिगार्डिंग वी हैव सम पॉइंट्स, सो वी हैव टू डिस्कस आल्सो, कुछ होगा। Aryl amine are generally more basic than the alkyl amine. So alkyl means, let's see, alkyl group we are taking CH2, sorry, C2H5 NH2 group I take. So RNH2 is alkyl group. So R I take C2H5. See which is the more basic. ठीक है. Aryl amine are more basic than the alkyl amine because in the case of this one, in the case of this benzene, if you take the aryl amine, so what will happen? Resonance, like you can see this double bond are resonance, okay, with the that means what, these lone pair are not that much available compared to this one, but here I want to pull those electron and rather they are giving electron to this one. That means we can say basicity of this one is less than this, so this is less compared to this one. Okay, so more means this also incorrect, generally more incorrect, less basic, generally more basic also correct. So correct answer is this one. Aryl amine are generally less basic than the alkyl amine. Yes, why? Because nitrogen lone pair electron are a delocalized interaction with the aromatic ring pi electron system, and which is called resonance. So we can say due to whatever the lone pair on the nitrogen, those are not available for donation. If it cannot provide, it will reduce. ये सभी को समझ में आया? Everyone you understood this? Yes or no? ये तो thumbs up दे दो, we'll go for the next. ठीक है, सभी को समझ में आ रहा है? तो give me thumbs up so that we can. ठीक है, चलो हम आगे क्वेश्चन करते हैं। ठीक है, आई होप कि आपको सभी को समझ में आ रहा है। ठीक, ओके, लेट्स प्रोसीड। Now here the question is, लंबा सा क्वेश्चन है, but sometimes psychology ऐसा होता है कि ये more theory we don't read, but just remember if theory is more, that is like simple question. Okay, so please do read the question in the exam. Okay, so let's read this one. On hydrolysis of compound, two components are obtained. Substance which we do the hydrolysis and it give us two substance. मान लो कि C plus D, मान लो Cb, ठीक है। One of which on treating with sodium nitrate, for example this one NO2 in the presence of HCl. So what is the product here? If we do this reagent, it should understood this is a digestion reaction, diazonium salt first, ठीक है, and give a product which do not form the iodoform base. That means what? After whatever the product we will get, it will not give us the iodoform base. That means what? It don't have any this wala group. Okay, we don't have any this wala group. ठीक है? It is given that the second one reduced tolerance reagent and the second one reduced tolerance reagent and filling solution. Okay, now let's see which is the, ठीक है। So if we hydrolysis this one, first one, ठीक है, if we hydrolysis this one, CH3 CH2, ठीक है, and after that we have NC, and we have this one also CH3 CH2 CN. Okay, everyone understood this? Okay, now let's see. Do the hydrolysis of this one. What is the substance we'll get? We'll get this one. Will get CH3. Do the hydrolysis of this one. So it prefer NH, so we will write this NHOH. This is HOH. So we can say we have this one NH2. Okay. And if we do the hydrolysis, so if we do the digestion of this one, okay, then we will have this one CH3, CH2, CH2, and we will have N triple bond Cl minus plus. Okay, everyone understood this now? So if we do hydrolysis of this one, hydroform based. Okay, just wait. Just wait on hydrolysis to compound. Then we do the hydrolysis. We have two substances B and C. On one of the treated with sodium nitrate, it will give product which does not respond to hydroform test. It don't respond to hydroform test. Okay. That means what? Whatever the product we will get, it is aldehyde. Aldehyde. Okay. Aldehyde. Everyone understood this? So, and we also state that it will give a tolerance reagent. So it will give the positive test for tolerance reagent. That means what? After this hydrolysis, we are supposed to get aldehyde. Okay. Aldehyde. We will get aldehyde. Okay. So we know this. If hydrolysis, during the hydrolysis of this one, what if substance will get CH3, CH2, CH2, and for this one, suppose you are doing the hydrolysis of this one. So how we are doing the hydrolysis of this one? Shortcut, let me tell you. We are adding water. Okay, we are adding water. So what we will do? We take here and we take here. Okay, so simply what we will do? CH3, CH2, CH2. Okay, first add water here, OH. Okay, double bond NH. After that, this carbon have more tendency to accept OH. So what we'll do? We'll break one bond here, one bond here, and we'll add 1 mole of water, another 1 mole of water, and here hydrogen. And we know this 2OH group is not that much stable here, not that much stable in single carbon. So what we'll do like this. Okay, and then we'll have CH3, CH2, CH2, and we'll have CO, OH plus NH3. If we do the hydrolysis of cyanide, we will get carboxylic acid. Okay. Now let's the hydrolysis of this one. CH2, CH2, and triple bond like this. So again we will do like this. Here N, again, and here OH, and we are removing this one bond. We are removing this one. After that, let's add 1 mole of water here. Here hydrogen, because nitrogen for the hydrogen. Okay. This side we have OH. Okay. And we are removing 1 bond here. And I told you this 2H group is not that much stable here. So what we'll do? We'll do like this. Like this. Yeah. Okay. We have H2, H2, or NH2. Okay. Everyone understood now? So the correct answer, which is the correct answer? And the correct answer is this. Okay. Everyone understood this? This one. So correct is this. Okay. Do you have any doubt? Anyone? Okay. Chalo, let's proceed for the next. Okay. Now solve this one. We are having methylamine. We have to react with diacetyl. Okay. And after that we'll proceed. So which is the product we will get here? Everyone please try to do this. So this group, I will do this with acetyl group and CO. So we can write CH3, CO. Okay. O, CO, this is CH3. Okay. Everyone understand this acetyl group. And this is react with this one. Okay, so what is the product we will get? If we react this one with aniline, NH2, and this is we have CH3. So what I told you, if you have nitrogen and you have carbonyl carbon, it will attack that carbonyl carbon. Okay, so it will attack this one here, and we break this. So what is the product we will get? Here we will have NHCO CH3. Okay, and this is CH3. After that, we are doing the bromination. Br2 CH3 COH. If you do the bromination, where this particular bromine will come? Okay, because this one, this is electron donating group, and this also electron donating group. Then we can say where is the more tendency to donate the electron. Then we can say here the more electron rich group, like position. Okay, or we can say this one is the like least. Okay, according to this one and this one, this is the position at which incoming group will attack. Okay, so what will do? These two are identical. NH2 group here means identical, so we'll add bromine here. What is the product we'll get? Next product we'll get is this one. NH. Okay, this is CO, CH3, and we're adding bromine here. Again, CH3. After that, we're adding water. We're adding water. Okay, so what will happen? This one. We have taken this now, this one. It will remove. Okay, and we'll have this one. NH2. Okay, this is bromine. And this is CH3. Which is the correct answer then? Then the correct answer is this one. Everyone understood this? So we can say this is the method to protect this bond, this one. Okay. Everyone understood this? How we did? We add this one with this, and we'll get this. After that, due to the bromination, we added the ortho position. After ortho position, we do the hydration. Okay, hydration in acidic medium. We will have this one. So the correct answer is. Everyone understood this? Shall we go? Okay, let's go to the next question. Now solve this. Okay, so here we are given a given compound, a given nitrogen containing aromatic compound A react with SnHCl followed by HNO3. Okay, so we have a substance A. Okay, it react with SnHCl. Okay, followed by HNO2 to give an unstable compound B. B on treating with phenol. Okay, give a beautiful colored compound C. That means we come to know this is a coupling reaction followed by diatization. Okay, so this is first method. After that 2, after that this is 3, and we'll have that colored compound. So let's proceed. How to solve this question? So first, let me write this. We are taking nitrogen containing compound. So this may be, this would be this one, nitro. And we know this nitro can be reduced by SnCl2, SnHCl. Okay, so it will be converted into NH2. Okay. After that, if you do the diatization, HNO2, HCl, then we will get this one. N triple bond Cl minus, this is plus. Okay. So after that, if you add this one with this phenol, then what is the product we will get? Okay. So let's me rewrite this one again. So we have this group N plus N. Okay. And we are taking phenol with this OH. Okay. We know this. This can, okay, this can push electron here. Okay, this is like we can say this is electron deficient. This can move in this direction. Okay, this can attack this. Have you understood this? So after this one, we can have this coupling reaction. This is what we call coupling reaction. We have this one, N double bond. After that we have benzene OH. Okay. Instead of this one phenol, you can take aniline also. Okay. Any group which can electron donating group, like this one you can also take O CH3. This also do the coupling reaction. It will give a colored compound. Everyone understood this? So shall we proceed? Now try to solve this. That is what I told you. ना अभी मैंने जो बताया. So here what we are taking, diazonium salt, equal, this is plus, okay. And after that we have aniline, NH2, ठीक, we have aniline. So ये क्या होगा? We'll have 4 bond between them. Then we'll have this one. तो compound हमारे क्या बनेगा? We'll have phenyl, N double bond N. This is NH2. So is the correct answer? D. Same logic, same. Everyone understood this? Okay. So shall we proceed for the next? ठीक है, हम चलो आगे बढ़ते हैं. ये same है जो we have done ना, same coupling reaction. Now solve this one. Okay, here we can see we just removing this one, this group. So it can be done by any dehydrating agent. Okay, we can remove this one. So if we see this one, dehydrating reagent is this H3PO3. So if you put H3PO3, it will remove this one and we will have this. It's simple one, this one. Okay, you have to just remember this. Okay. If you take this one, then we'll have phenol OH group here. Okay, so we cannot take the other reagent. Now try to solve this one. This also similarly that diatization coupling reaction only. Okay, so we know this. If we take aniline with this one, then what is the product we will get? The benzene here, N. Okay, triple bond plus Cl minus. Okay, and we'll react this with NN dimethyl aniline. So this is our aniline, NN dimethyl. To replace 2 hydrogen with 2 methyl group. Because this also have an electron pushing tendency. So what will happen? We can make bond between these two. So if we do means what will the product we will get? A benzene here, N double bond N. Here we have N CH3 and CH3. Okay. So which is the correct answer? The correct answer is this. I hope ये सभी को समझ में है. ठीक है. Now let's go for the next. These are similar questions. So now try to go. This is interesting one. For this one, you are supposed to know, like if you have this particular reagent, how to proceed. Okay. So just let me tell you. I hope you have pen and paper. You are try to solving with me only. Okay. So now let's see. Just think what is the product we will get. So first, what we are taking, we have aniline. Tell me, what is the product we will get if we take aniline in the presence of this one, NaNO2 in HCl? In that case, we will have diazonium salt. We will have diazonium salt. N2 Cl minus A plus A minus. After that, what we are taking? CuCN. We are taking CuCN. We know this. If you take this from anything with the copper, so it will replace here. So here we will have this one. Cn plus N2 plus CuCl2. Okay. And after that, what we are doing? We are doing the hydrogenation. Hydrogenation means we reduce with the hydrogen. So we are taking hydrogen in the presence of nickel. Okay. Then what is the product we will get? Product we will get is this one. So we are reducing this one. So we have like this. I will redraw here. We have like this. C triple bond N. So what I told you, reduction means you have to add hydrogen. First, you break this one hydrogen, second hydrogen. So you will have CH2, NH2. After that, what you are doing? You are doing HNO2. ठीक है, HNO2. HNO2 means we'll have this one. CH2N Cl. ठीक है, and after that is there anything? ठीक है. So if we add water, means then we have this. ठीक है. So this one. Everyone understood this? सभी को समझ में आया ना everyone? ठीक है. So shall we go for the next? ठीक है, हमारे पास कुछ मिनट है. Let's do this. Everyone try to do this. Which of the following nitro compound does not react with nitrous? To react with nitrous, ठीक है, nitrous acid तुम्हारा क्या होना चाहिए? नाइट्रो ग्रुप. सॉरी, which of the following nitro group compound does not react with nitrous acid? ठीक है, क्या होना चाहिए इसमें? If that is a what we can say, if this particular NO2 is add to the 3 degree carbon, then it will not react. It will not react because of the absence of acidic hydrogen. So here we can see 3 degree. This one is 2 degree. This is 2 degree, and this one is 1 degree. Okay, so what will react? This will not react. Okay, to react with this nitrous or a nitro compound, you should have that alpha hydrogen. ठीक है, acidic alpha hydrogen. Then it reaction will possible. ठीक. This one. Nitro engine react with HNO3 at 80 to 100 degrees Celsius form the compound. Which is the product? We have nitro engine. With HNO3 H2 SO4. Which is the product we will get? We know this reagent doing the nitrous means we are introducing NO2 group. ठीक है, we are introducing NO2 grouping. Which is the product we will get? The product that is this one. NO2 is electron withdrawing group. For this will give us the meta product. ठीक है, so now do this one. After that we will stop there. So if we, what is the product we will give? We do this with Z NH4Cl, then we will have this one NH, one time reduction. This. Okay. So I hope you understood. If you don't, means you just like WhatsApp me or whatever in the group, or you can just ask me. If no, means okay, fine. Anybody wants to ask anything? Mahima, Ritu, Chandana, anybody? If it is not, then you are good to go. Okay, and thank you for attending the class. Thank you.